Our project addresses a common issue. Readers often spend more time choosing a book than actually reading, especially when they have limited time or a specific mood. Our target users are students and casual readers who want quick, relevant recommendations without using large, complicated platforms. For person A, I was responsible for data ingestion, the logical view. I loaded the raw dataset, cleaned and standardized inconsistent metadata, filtered relevant records, and handled missing values. I also implemented normalization and tokenization for key searchable fields like title, authors, subjects, and categories. This produced a clean, structured representation of each book that the indexing and ranking modules can reliably use.
And I built a core search engine that retrieves and ranks books. I implemented a custom inverted index which maps terms to documents and stores term frequency information. So lookups are fast and scalable. On top of that, I implemented TF-IDF ranking with cosine normalization so the system can score how relevant each book is to the user's query and return a top 10 ranked list. I also made the ranking layer integration ready by separating baseline relevance from re-ranking. And that allowed us to add user preference and context signals like preferred author, favorite author, mood, and reading time preference without changing the core retrieval logic. In addition, I added a result explanation field so we can show why a book was ranked highly, and this gives us a strong baseline search that is easy to extend for personalization in the final demo.
UI UX, and I worked on the personal model, including the preferred authors and genres, the recommendation system, and other features in this web app. So on the front page, you can set the context with the mood and or time, and on the profile page, the user can set the preferred authors and genres, and that'll stay in session, and they can also view their bookmarked books. So we'll start off by searching for Romeo, and we'll get the top 10 results here, and if we click view, we can see the ranking score. This has the best ranking score, and down here has the lowest ranking score. And we can also see the rationale here. It just matched the query term Romeo because it's in the title and such. But we can also change the context. So if you want a short reading time, we'll get books with lower page counts now. So page is 40, and it has the highest ranking score. And vice versa. If we want longer pages, we'll get longer pages. But if we don't want to change the context, we can also change the user preferences. So if we search for, say, space, we'll get, these are the normal results. We'll get space and such. And we'll pick an author, say Sharon Green, and we'll set that as our favorite author. And we'll also pick fiction as our favorite genre, say preferences. And we search for space again. We'll get a novel by Sharon Green. That will be the first result. And it's also fiction. And we'll get more fiction as well. But Sharon Green will be the top result. Okay, and there's also the bookmarks. So if we just reset everything real quick. We search up green eggs. So the recommendation system is based off the bookmarks. So we'll bookmark this, and because this is a juvenile fiction novel, We'll get more juvenile fiction novels recommended, and the recommendation will update as you bookmark. So we just updated bookmarked the Dr. Seuss book, and we're starting to get more Dr. Seuss now. So that's basically the project. And when it comes to limitations in future work, I think the context can be made easier. And instead of the user having to input words to set the context manually, And if it could learn from the user's activity during the day, then it could be a lot more convenient. Additionally, the recommendation system can be more accurate if it incorporated more of the user's activity. But that's about it for the project.